Let's look at the questions that are posed here. So the first question says, what are the measures of angle A and angle C? So I didn't ask you to shout them out. So could you please write that down, and then you must explain how you derived your answer, and it cannot be from Tatum. So please write down your answer. If you didn't see the heading at the top of your paper, how would you know what angle B and angle C are? I want you to think about it. Without any knowledge other than you have a right angle in there and the markings that are on the picture. So would somebody like to explain why Tatum said angle B and angle C are equal to 45 degrees? Mr. Ruby?
Oh, my. Is that a...
Yes, would you like to explain?
Not really. I don't know how to say it, but that really is.
How do we know?
Because the two sides are equal and the angle is opposite.
Thank you. That's exactly correct. If two sides in a triangle are congruent, then the angles opposite those sides are congruent. And in addition to that, since we know that the interior angles in a triangle add up to what? 180 degrees, that leaves 90 degrees left over for angles B and C. And since angles B and C have to be equal, divide 90 by 2, and you have 45 degrees, and please mark this in here, and 45 degrees. So this is what's called a special triangle. A 45, 45, 90 triangle. So let's answer question number 2. Write the Pythagorean formula. Write an equation in terms of x and h. So look at the side lengths that are listed there by substituting the side lengths into the formula. And then I want you to answer question 3, solve for h. Your answer must be in simplest radical form. And then stop at question number 3. Do not go on to 4. Question. You can say it's an isosceles right triangle, but we are using the isosceles triangle theorem. That's our explanation. Yep. But I don't want you just saying because it's an isosceles triangle, because that doesn't explain. Does that make sense? Yep. Yep. So why are we not writing some of this? I have eyes boring from your forehead onto your paper. I can see what you're doing. Wouldn't that be creepy? Totally creepy. So let's just start with let's start with a squared plus b squared equals c squared. That's Pythagorean's theorem. So we're going to plug in something for a, something for b, and something for c. What are we going to plug in for a? X. How about for b? X. How about for c? H. And so then we're going to go up here. We get x squared plus x squared equals h squared. Now we did this yesterday. What's x squared plus x squared? 2x squared equals h squared. And they want you to solve for h, correct? So over here, if I solve for h, I've got the 2x squared equals h squared. How do I solve for h? So I'm going to take the square root of both sides. And so I end up with, I'm going to use the symmetric property. I'm going to flip it. And so h is equal to, can I take the square root of 2? No. What's the square root of x squared? X. So I get x rad 2. So that means the hypotenuse is equal to x radical 2. Now all sides are in terms of x. We've got x, x, and x rad 2. So it says redraw the triangle above, substituting your answers from step 3 for H on the diagram. Well, we just replaced it, right? And so I want you to realize that any other math class other than geometry will use the following triangle for a 45-45. So you might want to draw this. So I'm going to make an isosceles right triangle. And so that means that this is 45 and 45 degrees. And instead of x, x, x rad 2, what do all three of the sides have in common? An x. What if I divide each side by an x? What's x divided by x? 1. Right? And so this side would also be 1. What's x rad 2 divided by x? Rad 2. This is what every other math class after this is going to use for the right triangle. 1, 1, rad 2. And that's what I would prefer that you remember, because I'm going to teach you how to solve these differently. So, for instance, let's go back up here and let's just look at a problem. What if I gave you the following? Let's say that I said that x was equal to 4. What does this side equal? 4. What does this side equal? 4 rad 2. So that's what's nice if you know x, x, x rad 2. If you know one of the sides, you can easily go, oh, well, the hypotenuse is 4 rad 2. Simple. The problem is, what if I told you the hypotenuse was 4? That means that x rad 2 is equal to 4. That's harder to figure out what the side lengths are. Wouldn't you agree? Okay. And I just want to prove to you that this does follow Pythagorean's theorem. So we're going to take the legs, 4 squared, plus 4 squared equals 4 rad 2 squared. So 4 squared is 16 plus 16 equals, what's 4 squared? Rad 2 times rad 2? 2. And so 16 plus 16 is 32 equals 16 times 2 is 32. Doesn't that check? So it works. Okay? So let's look at the back. I'm going to teach you a method which is different than your book. Okay? So you're going to identify your triangles as a 45, 45, 90, or what we're going to do tomorrow, which is a different one. There's only 2 special right triangles. And so as we look at this one, look at triangle 1. I realize that it'd be pretty easy for this particular one to go, oh, okay, that's 9, so that's 9, and that's 9 rad 2, correct? Yeah. So let's just use that knowledge, because it gets harder if I ask you to solve this triangle here. That's not quite so easy. So because of problems like this, I'm going to show you how to solve all 45, 45, 90s the same way using proportions. Didn't we just learn about proportions? Okay, so we're going to use proportion rules. So as soon as you look at a triangle and you realize, oh, it's a 45, 45 because it's an isosceles right triangle. So you're going to list it as 45, 45, 90. I'm going to write that out. And then you're going to say to yourself, what are the side lengths across from each of these angles? So across from the 45 degrees, so if I put my 45 in here and my 45 in here, across from this 45, didn't we just say that this was 1, 1, rad 2 earlier if we took the x's out, right? And so across from this 45 is 1, across from this 45 is 1. So I want you to put below the 45, 45 is 1 and 1. And then across from the 90 degree angle is what? The rad 2. So then we're going to put underneath the 90 radical 2. And then you're going to draw lines like a fraction bar, and you're going to have equals, equals. And then we're going to put underneath the actual side measures that they've given you here. So across from this 45 is really 9. So that's what we're going to put below. Across from the other 45 is what? No, across from this other 45 is what? An x. So that's where we're putting here. And then across from the 90 is a what? A y. So that's where we're putting here. So then you have to decide out of these three ratios, I can use this one because I have a whole ratio with this one and create a proportion. True? Or I can use this one with this one and create another proportion. And so we can solve it by saying 1 is to 9 as 1 is to x. And if I cross multiply, doesn't x equal 9? So look at the second proportion. So the second proportion would be 1 is to 9 as rad 2 is to y. So if I cross multiply, don't I get y is equal to 9 rad 2? So this method does work, correct? So let's use it in triangle 3. So let's move it up, because this is the one that's the difficult one. So as soon as you realize that you've got x and y, even though it's x and y, you've got these markers telling you that they're equal, you know that it's a 45, 45, 90 triangle. So I'm going to write out 45, 45, 90. And then below that, what are you going to write? You just start learning. It's 1, 1, rad 2. And then we're going to create three ratios. What is across from one of the 45 degrees? Y. What's across from the other 45? X. What's across from the 90? 3 meters, right? And so we're going to use two ratios. I'm going to start with these two, just because they're next door. So let's solve that ratio. So when I cross multiply, don't I get x radical 2 equals 3? How do we solve for x? What's happening to x? What's happening to x? What's that operation between x and rad 2? Multiplication. How do you want to do it? Divide. So we're going to divide by rad 2 on both sides. What did we learn yesterday about having a radical in the denominator? You can't have that. So we've got 3 over radical 2. That is considered unrationalized. So you remember how we rationalize that? So whatever the radical is in the denominator, in this case it's rad 2, you're going to multiply both the top and the bottom by that radical so that we don't have a radical in the denominator. We can have a radical in the numerator, that's okay, but not in the denominator. So in this case I get x equals 3 rad 2 all over 2. If the two numbers that are outside the radical, right here, if they can be reduced, you need to reduce them. But they can't, so this is my value for x. And from there it's hard to see, well, wouldn't that be what y is going to be as well? So if you know you have a 45, 45, 90, and I set up the second ratio from here to here, aren't they going to be identical except I have a y? So I'm completely fine with you saying that y is also equal to 3 rad 2 over 2 because they are both the legs of that 45, 45, 90 triangle. So what I would like you to do is to try 2 and 4 on your own. And while you're doing it on your own, I'm going to do it up here. And of course, well, you just have to ignore what's following. I have yet to figure out how to make that go away. So you go ahead and do those on your own. I'm going to cover it up. And then when you do have your answers upside down, just to let you know. All right, so share your answers with those around you. See if they can figure out. I realize you have the answers underneath there, but you have to be able to figure out how to get to those.
I like this lesson.
Right?
This is only half of this lesson, right?
Correct.
So it's harder. Or is it
This actually, this is as hard as it gets. I mean, it really doesn't get much harder other than the word problems.
Oh.
So let's look at these. Let's look at 4 first. Let's look at 4 first. This one's the harder one. So you have to identify that's a 45-45. Why? Because the legs are equal. And right at your 45, 45, 90, 1, 1, red 2, and then across from the 45s are x and y, and across from the 90 is 7. And all I did was choose 2 of them to be a proportion. You have to choose 1/2 of that proportion where you have a full ratio. And then don't forget that you have to rationalize any denominator that has a rad 2 in there. So your assignment is 7 through 13 all.
7 through 7 all.
In the answers, they said like x equals y equals that answer, or they did like.
All right, so the question for this particular one was, can't I just use Pythagorean theorem all the time? Well, on the 45-45s, yes. But on 30-60-90s, no. So let's go ahead and look at this one. The 45-45-90, and that's important for you to realize this, the 45-45-90 comes from a square. So you put a diagonal through a square, you get the 45-45-90 triangle. The 30-60-90 triangle comes from an equilateral triangle. So as you're looking at this picture here, this is an equilateral triangle. So all 3 of these sides are equal. And we have an altitude coming from one of the angles. Are all equilateral triangles isosceles? True or false? True. So what did we learn about an altitude coming from? This could essentially be a vertex angle of an isosceles triangle. What does this altitude do to this side? It cuts it in half. So I know that this side is equal to this side. And because it's an equilateral triangle, I know that this side is equal to this side. And then don't they share a side? So the triangles are similar by SSS. And what are all 3 angles in that equilateral triangle equal to? 60 degrees. So that means the measure of angle A is 60 degrees. And what's the measure of angle B? 60 degrees. What's the measure of angle ACB? That's from A to C to B. Oh, ACB. That's also what? 60 degrees. So then I already mentioned in question 2 that CD is an altitude of the equilateral triangle. So what does CD do to AB? Okay, so you're going to want to put that in here. Bisects it. So that means that AD is congruent to DB. So based on your answer to problem number 2, I want you to think to yourself, not out loud. Think of what the measure is of AB, AD, and BD in terms of x. In terms of x. Think by yourself first. Now share it with somebody. Share what you think. Ian, chat with the beautiful Zoe behind you.
Yes, yours can. Don't be shy.
Mushat, keep
You're
to
right.
yourself.
I'm too shy.
Yeah, Ian's such a shy person. All right, so what do we think about the distance from A to B?
I do not know.
Is AB plus 2.
The distance from here to here?
AB equals 2x.
Yeah, because if AC is 2x and CB is 2x, doesn't it make sense that AB would be 2x? So we've got 2x from here to here. And so AB is 2x. So if AB is bisected, what is AD going to be?
1x.
Yep,
X.
just an x.
Oh,
And
yeah.
so that means that this is just an x. And so AD is an x and BD is an x. So far on the triangle, and if you look at just half of this, so if we look at just this side per se, so you could highlight this. On this triangle, we have a side that's x, a side that's 2x, and then you're going to use Pythagorean's theorem to find h. So, look at question 4. CD is an altitude of the equilateral triangle. What does, let's think about this for a minute. What does CD do to angle ACB? So, what does the altitude do to this angle here?
That's in half.
It cuts it in half. So I know, and so put your markers in there, I know that this angle 1 is congruent to this angle 2. So you might want to write that down. It bisects it. So not only does that altitude bisect the opposite side, remember it also bisects that angle. And based upon that, find the following angle measures. So to yourself, what is angle 1 and what is angle 2? What do they equal?
30.
30 degrees and 30 degrees. So let's put that in the picture. So angle 1 is 30, oops, it'd be helpful if I had it on pencil. Angle 1 is 30 degrees. And angle A, we said already, was 60 degrees. So there's our 30, 60, 90 triangle, because this is also a right angle there. So if they tell you that you have an equilateral triangle and an altitude is drawn from one of the vertices, they're creating for you a 30, 60, 90 triangle, right? Just like with a 45, 45, if they gave you a square and you had to draw a diagonal through the square, that's how you got your 45, 45, 90. All right, so let's finish it up. So we already highlighted, well, I highlighted the opposite side, so it doesn't matter. You can highlight triangle DBC if you want to. It is also a 30, 60, 90 triangle. I want you to write the Pythagorean formula, write an equation substituting the side lengths of the three sides of that triangle in there into the formula. And then solve the formula for h and leave your answer in simplest radical form. So if I were you, I would do that up here because you're going to have no room down there. So start with your formula. A squared plus b squared equals c squared. And then you are going to sub in for a, b, and c. A and b are what to the triangle? Here's your triangle. A and b are what on this triangle? The legs of the hypotenuse. I can't even talk today. They're the legs, right? So what's the length of this leg? X. So you're going to put x in there. What's the length of the other leg? H. Because the 2x is the hypotenuse, right? Right? Because the 2x is across from that 90-degree angle. So that 2x goes in place of c. Well, that's a terrible x. Let's try that again. Alright, so then when you square x, what do you get? X squared. When you square h squared. What happens when you square 2x? You have to square the 2 and the x. So 2 squared is 4. X squared is x squared. If we're solving for h, what do we want to do now? I want to get the h squared by itself. So I want to subtract what? X squared. So we're going to subtract x. Actually, that's a like term, isn't it? So we're going to subtract x squared from both sides. So I get h squared is equal to 3x squared. Right? If I have 4x squareds and I subtract 1x squared, I get 3x squareds. And then how do I solve for h? Take the square root of both sides. So h is equal to, can I take the square root of 3? Nope. Can I take the square root of x squared? Yes. So we get x radical 3. And so that means that h here is equal to x rad 3. So down below, let's answer those questions. So solve the equation written in step 4 for h. Leave your answer in simplest radical form. So we've got h is equal to x rad 3. And then you're to redraw the triangle above and substitute in your answers for step 5. Well, we already wrote that in the picture, so it's no need to do that. And then summarize your findings. Well, here's our summary of our findings. If I have and let's use what we used yesterday. If I have a 30, 60, 90 triangle, take away the x's above. So remember yesterday our pattern, it was x, x, x rad 2, and we took away the x's and we had 1, 1 rad 2, right? So if I take away my x's up here, I've got 2x and an x rad 3. So notice that across from my smallest side, this is going to be across my smallest angle, this is going to be my smallest side. Across from my middle angle, this is the larger leg. So you always have a long leg and a short leg on the 30/60s. And so that's actually bigger than x. And then my largest side is my hypotenuse, which is 2x. So you always want to go in order of 30, then 60, and then 90. So if I take away the x's, what do I have left? Across from 30 is what? Take away the x, 1. Across from the 60, take away the x, rad 3. And across from 2. So I've got 1, rad 3, 2. So that's our new pattern of numbers. So down here, we're going to put 1, rad 3, and 2. So you got to learn those. And then we'll end up making 3 sets of ratios, just like we did yesterday. So let's go to the next page and actually do some problems. So let's look at, I'm going to do problems 1 and 3 with you, and then you're going to end up doing 2 and 4 on your own. So in both of these, they give you one of the 2 acute angles in that triangle, so, and they kind of have to do that for you to know what's going on. So we're going to start off with the fact that this particular triangle here, if that's 30 degrees, then I know that this is 60. And so I'm immediately going to write 30 in order smallest to largest, 60, and then 90. And then my pattern is 1, rad 3, 2. That's the part you have to learn. And then we're going to create our ratios. What is across from the 30 degrees? X. So these ones, it's important that you get them absolutely correct as to what's across from what angle. So across from 30 is x. So we're going to put an x here. And then across from 60 is what? Y. So a y goes here. And then across from my right angle is what? 10. So the 10 goes under here. So then we're going to choose any of the 2. Well, we've got one full ratio here, correct? So I'm going to use that full ratio, the 2/10, with either of the other 2 ratios. So let's start. So I have to write 2 ratios in order to solve this one. So unlike yesterday's, where once we found x, we would have found y, this time I can't do that. So I'm going to set up 1 is to x as 2 is to 10. Can I do anything before I cross multiply?
Simplify.
Yeah, I'm going to simplify the 2 and the 10. You can only simplify vertically, right? In proportions, you cannot simplify diagonally. So don't fall into that trap. So 2 goes into 2 once and into 10 5 times. And so now when I cross multiply, x times 1 is x, and 1 times 5 is 5. So there's one of my answers. X is 5. And from here you could then use Pythagorean's theorem, but to me that's a whole lot more work. Why not just set up another proportion? So 1 is to x as, I'm sorry, I don't want x, I want y, don't I? So 1 is to y. And should I use 2/10 again?
Yes.
Well, yes, but can I use its reduced form? Oh, hang on. I'm totally writing the wrong thing. It'd be handy if I'm paying attention, right? So rad 3 over y is equal to 1 over 5. And you could have put 2 over 10, but since we already reduced on the other one, why not reduce it here? So now when I cross multiply, I have 1 times y is y. And then 5 times rad 3, you always write the number in front of the radical, never the other way around. And so this one, we get 5 rad 3. Easy. So then look at number 3. So this time they're giving you one of the legs, and you have to find the other leg and then the hypotenuse. So they've given you 60, so I know that that one has to be 30. So I've identified it as a 30, 60, 90 triangle, and my pattern is 1, radical 3, and then 2. And then we're going to set up our ratios. So what is across from the 30? X. What is across from the 60? 12. And the 90? Y. And so our full ratio is here. So that's the one that we're going to use with each of these two. So we're going to set up 2 different proportions. So one proportion is 1 is to x as radical 3 is to 12. How come I cannot reduce radical 3 and 12? You have one number under a radical and one number outside the radical. They cannot communicate with each other, so therefore you cannot simplify them. So we are stuck with cross multiplying. X times radical 3 is equal to 1 times 12. And then I want to solve for x, so what do? Divide by radical 3. Can I have a radical in the denominator? Nope. So you want to rationalize by multiplying numerator and denominator by rad 3 over rad 3. And so that leaves us with 12 rad 3 over 3. Am I done now?
No.
Nope. These are both outside the radical, so you have to simplify them. Doesn't 3 cancel into 12 4 times? So I get a final answer of 4 radical 3. So there's one side. So then let's find the hypotenuse. Radical 3 is to 12 as 2 is to y. So when I cross multiply, I've got y times radical 3 is equal to 2 times 12 is 24. Again, when I solve for y, I'm dividing by rad 3, which we can't have, right? So we're going to rationalize by multiplying numerator and denominator by that radical. And we end up with 24 radical 3 over 3. Can I have that as an answer? No. So the 3 cancels into the 12 or the 24 8 times. And so my final answer is 8 radical 3. Bless you. So then I want you to do 2 and 4 on your own. Obviously you have the answers down below so you can check. But you're going to work on 2 and 4 on your own. And if you can't get those answers, bless you, then you can seek help from those around you. Misha, can I see your paper? Are you done? Yeah.
No.
No, then go sit up there. It's not social time, because I know that's exactly what you're doing. Uh-huh. So check your answers down below and see if you can get those using that method. Not using that.
We should play it instead of whiteboards.
Because they're a lot rougher. The girls are too nice. Yes, they are.
Girls are vicious, are you kidding me?
Okay, they do pull hair and scratch, but
Yeah,
not
I'd
in-
take guys punching over that.
All right, so my point to some of you who were not showing work, this is what you should be showing. So if you have nothing, not much. Now this one down here, I could understand on this one down here why you might not show work. Because you could reason your way on number 4. But still. All right, so any issues, problems, or concerns with that? Okay, so we're going to practice some.